Greetings everyone! We are in handheld shaky cam mode. So hopefully you don't get queasy. I'll try to be steady here. John Audio Tech steady shot mode here. What you're looking at is a bunch of JAT amplifiers. I had a request come through the mail. Somebody wanted to know if they can run the JAT501 with a 2 ohm load in Class A mode. But the good thing is the supply voltage is only plus or minus 12 volts, and I think you could do that. Though when I did a video about the JAT501 in Class A, I kind of mentioned why. I'm not a big fan of Class A amplifiers, and I'll mention that later, but look at this. This goes back to yesteryear memories. Here's the thing that kicked it off, the JAT501 prototype board. All the steps I went through, modifications to make it work right. I wanted to get a nice stable amp with decent low distortion performance. That didn't take a lot of components. I mean, it's not a simple amp. It has 13 transistors. But, you know, it's a nice performing amp. With 4 ohm loads you can get around 100 watts, probably a little more, but decent little amp. And then collaborated with the guy who knew how to run the software to make boards. I still need to learn that. Sit down and learn that. And where is it here? This guy here, this is the first one. And there was a lot of issues. I wanted to redesign it. So I went back and forth and came up with this board, much better design. And that was the JAT501 amp, and there's the little happy chip guy waving to us. There's no chips used on this board, but there's the little chip amp guy there. And we have the inline board, as it's called, all the output devices that mount to a heat sink. Thermal stability devices, drivers and all, are in line there. And used an Intel heatsink. What Pentium was that used? Pentium something or other. And then we had the JAT Easy amp here. It's a much simpler amplifier with Darlington outputs. A lot less components, as you can see. See how much less components on this board? And I had a hell of a time getting this thing to work. It would always burn out its outputs. They would just die for no reason. I tried to catch the event on the oscilloscope. I never could. And, well, I found out one day it was just a connection. The compensation cap wasn't soldered. There was a bad solder on the bottom. Once I did that, it was perfect. And even on the audio analyzer, it's at 1 kilohertz, it was putting out pretty low distortion, down in the 0.00 something. So yeah, that was surprisingly good. Oh yeah, the JAT801. Will I ever finish this thing? So this is kind of like a 501, but with a paralleled output stage, some change components, so it can operate at higher voltage, higher power, and probably push no more than 200 watts out of this thing. But it's you can see there's bodged on parts. It's not done. It needs some work. I do have a schematic of the reworked amp. I just need to fiddle-faddle around with it and hopefully get this done one of these days. Okay, so yeah, now to move on to the actual subject of the video is to bias up a JAT501 and see how it performs. I think I'm going to have to change a part to allow the bias current to be set real high and see how it works. I also want to find the optimum class AB bias point of the JAT501 using the audio analyzer, see where the distortion is the lowest. So, now that I've yacked on for almost 6 minutes, let's get to it. It's always a good day when my DigiKey order comes in. I do a little happy dance and I sing. Then I open the package and realize that I forgot to order something I needed. Okay, I'm going to play with the bias control here and just see how the distortion performance works out. So it's connected to the load there, and this mess here connected to the analyzer, and I'll twiddle the control. And I got the power supply on, plus minus 32 volts. So we'll start out with the bias control, or I should say the bias turned all the way down. Okay, to perform the bias test, I'm going to test at 1 kilohertz, 1 watt, into an 8 ohm load. You want to test at a lower power because that crossover signal relative to the actual test signal, you want it to be fairly close. You know, if I tested with a large signal, it would diminish the effect. So testing at 1 watt is good for running this test. And with the bias turned all the way down, you see I'm getting all of these harmonics. See how they just continue on out. And distortion, though it's not bad, it's 0.012. And the bias, I measured the current at 3.8 milliamps. So yeah, I know the amp could do much better than this. And of course, this is set to the minimum level. I'm not sure if the control will go any less than that, but we already know we're getting into some harmonics here. And yeah, because the effect of that crossover is kind of a rapid changing notch, you're going to have a lot of harmonics, higher order harmonics in that. So let me crank up the bias and see what happens. Bias current is now at 18.4 milliamps. You can see the distortion has decreased considerably down to 0.0037. Notice those harmonics down here. We used to have a big range of harmonics right here, and they've decreased considerably. Now 18.4 is still pretty low, so let me crank it up higher and see what happens. Okay, bias is up to 48.4 milliamps. Distortion is down to a very low 0.0018. You can see the harmonics are a lot lower. This other stuff here is just 60 hertz AC line noise getting in and its harmonics. And I think this up here is probably just electronic noise from switch mode supplies or junk getting in. But, you know, the harmonic series here is really low, way below a 100. There's a second order that's just popping up just a bit above 100, minus 100 dB. But yeah, distortion is really low. So what I'm going to do now is just continue taking measurements and recording them, and I'll come back with the results. So here are the results. As I went higher and higher, I stopped at 110 milliamps because, as you can see, the bias, or I should say the distortion, just bottomed out and stayed there. And it's all 0.0018. 17, 18, 18. So as I turned the current up, it just went down and stayed flat. So this amp really doesn't need to be biased beyond 50 milliamps. I can probably test a number in between 18 and 48 and see what it's like. But yeah, I'd say 50 milliamps is all this amp needs for bias. And you could probably go a little less if you want it to run even cooler, but that's not bad at all. Bias stability is great on this thing. You know, I set it at 0.12. That's the total current draw. And it just stays there, it never changes. So thermal stability on this amp is excellent. That was the whole idea, is to build a stable amp that's performs pretty good. Alright, so that's the result of that. And what I'm going to do now is lower the voltage and see if I can crank up the bias for Class A operation into a 2 ohm load. I dropped the voltage to plus and minus 12 volt rails. I twiddled the bias knob up to 1.47. It dropped a little bit since then. 1.45. That's as high as it'll go. I'm at the limits of the dial, so I can't completely bias it for a 2 ohm load. I'd have to change a resistor in the biasing network to allow for more current. But what is interesting is at 1.47 amps, the distortion is extremely low, 0.0011. I did a measurement at 70 milliamps of bias as kind of just to see what it is at normal AB bias, and it's a little higher than it was at full, at the limits of my supply, plus or minus 32 volts. It's 0.0025. And there you can see the distortion. It actually dropped a little bit. Now it's at 0.00106. Here's the JAT501 schematic. Bias control circuitry. So when this transistor's turned on more, it tries to pull the base voltages closer together, which means less current is going to flow through them, and it turns the, or I should say it lowers the bias current in the output stage. But when I set this to its lowest position, that's going to shunt more current this way instead of into this bias transistor, which turns this more towards off, or in other words lowers the current, and that widens the voltage across these points, allowing more and more bias current to flow, increasing the output stage bias current. And I'm at the limits, so this limiting resistor here prevents from turning the current up too high. So what I have to do is put a lower value in, and that should increase the current, well, take it from the top here, John. That would allow more current to flow this way instead of into the base, which turns this transistor off more, in other words lower current, which allows this voltage to get wider, in other words more current flowing into the bases of the drivers, and increases the output stage bias, or idle current. So let me see what happens here. So running at 1.37 amps, I'm going to jumper a resistor across R17 right there. It's that resistor to the right of the trimmer. Let's see what happens. Okay, yeah, I can't do it with the camera here. It's hard to hold that on there, but when I did, it jumped up to 2.2 amps, so I need a smaller value resistor than this 1K. But yeah, this thing's sitting here. It's getting pretty warm. And eventually it'll be too hot to touch. Look how big this heat sink is. And this is why I don't really care for Class A amps. They just use so much power just sitting there idle. They develop a lot of heat. Okay, I added the resistance in parallel so I can set the bias higher than it was before. And it's idling here at, well, it's actually putting a signal out, but that's all idle current, because the signal current, you know, it's just about 1 watt, so it's hardly going to show up there in the measurements. And yeah, them coils or resistor, they're wire around, they're getting pretty hot. I can't touch them. The load is set for 2 ohms now, and yeah, the performance has degraded. It's 0.01, which is not bad at all in the hi-fi audio world, but it's not nearly as good as it was. I'm just curious if I set it to 4 ohms. Yeah, it's really good there at 4 ohms, 0.0029, about 0.003. But at 2 ohms, it really takes a hit. I set it back to 2 ohms and it jumps up again. Okay, so now I'm finding the output power. We're back into normal Class AB biasing here. And if I zoom in on the screen there, see we're clipping. And let's turn that down, get that out of clipping. And get some waveforms on the screen, so I can take a measurement there. So 6 volts. So 6 volts squared is 36 divided by 2 ohms, 18 watts. That's how much power I can get out of this thing. There's the power draw there. 24 times 1.3 amps. It's the actual power draw. To get 18 watts out of the amplifier. Okay, so now I'm scoping across one of the emitter resistors in the output stage so I can set up the bias for Class A. So you'll see this kind of half wave pattern because I'm only scoping half the output stage. So what I want to do is turn the bias up until that becomes a full sine wave again, and then we'll be biased to handle a 2 ohm load. Okay, cranking the bias up. Okay, right about there. Probably should add just a touch more to make sure. Looks kind of distorted. I'll probably have to check the output. Now I'm starting to distort on the top. Probably in this range here. Let me stop the signal. Okay, I'm clipped back on the output again. So let me turn that signal off. And we're drawing a little over 2 amps of bias current, 2.14. So I'm going to say that it's not feasible to run one of these John Audio Tech 501 cards at Class A with a 2 ohm load at plus minus 12 volts. Just too much heat. Requires a lot of heat. Now this heat sink's facing down. It's not sideways to let air go through it, but still I bet it would get too hot. You probably could get away with it if you run a fan across it. Maybe increase these emitter resistors on the output. Of course, you have to do this modification so you can turn the current up high enough. But yeah, it's just so much waste heat. Like I say, I'm not a big fan of Class A amplifiers because it just wastes so much heat. Get everything hot. If you're going to build a Class A amp, you got to really build it out to deal with the heat. Now, in a previous video, I did this thing Class A with an 8 ohm load at higher supply voltages and got much better results. So that's feasible. But again, what's the point? Class A, you can get the distortion so low with this thing at optimal bias. And I figured out it's around 50 milliamps, Class AB. So yeah, fantastic little amp when you do it that way. So what else can I say? I'm not going to do all the power test, distortion test and all that for this. I don't think we'll see anything interesting, but yeah, I'll wrap it up here and just say I'm going to say it's not feasible to run this thing Class A under the conditions, especially with such a low impedance load, 2 ohms. So there you go. Thanks for watching, and we'll catch you on the next one.